captured the imagination of humankind for centuries, inspiring both fear and fascination. These natural wonders are not just mountains, they are dynamic geological features that play a crucial role in shaping the Earth's surface and influencing its climate. Let's delve into what volcanoes are and how they come into being. A volcano is a vent or opening in the Earth's crust through which molten rock, gases, and ash erupt onto the surface. These eruptions can vary widely in intensity, from gentle lava flows to explosive events that eject ash and rock high into the atmosphere. Volcanoes form at tectonic plate boundaries, where the Earth's crust is either colliding, spreading apart, or sliding past each other. There are several types of volcanoes, each formed by different geological processes. Subduction zone volcanoes. These volcanoes form at convergent plate boundaries, where one tectonic plate is forced beneath another in a process called subduction. As the descending plate sinks into the Earth's mantle, it melts, creating magma that rises through the overlying plate to form a volcanic arc. The Pacific Ring of Fire, home to many of the world's most active volcanoes, is a prime example of subduction zone volcanism. Mid-ocean ridge volcanoes. These volcanoes occur at divergent plate boundaries, where tectonic plates are moving away from each other. Magma from the mantle wells up to fill the gap, forming underwater mountain ranges known as mid-ocean ridges. As the magma solidifies, it creates new oceanic crust and occasionally breaches the surface to form volcanic islands. Hotspot volcanoes. Hotspots are areas of exceptionally hot mantle plumes that rise from deep within the Earth. These plumes can create volcanic activity far from tectonic plate boundaries. As a tectonic plate moves over a hotspot, it generates a chain of volcanoes. Famous examples include the Hawaiian Islands and the Yellowstone caldera. Volcanic eruptions occur when pressure builds up within a magma chamber beneath the Earth's surface. This pressure can be caused by the accumulation of gases, the movement of magma, or the addition of new magma from deeper within the Earth. When the pressure exceeds the strength of the surrounding rock, an eruption ensues. During an eruption, magma is expelled from the volcano through the central vent or fissures in the volcano's flanks. The type of eruption depends on the viscosity of the magma and the amount of trapped gases. Effusive eruptions. These eruptions are characterized by the relatively gentle flow of lava, which can travel long distances from the vent. Effusive eruptions typically occur with low viscosity magma, such as basalt, and often result in the formation of lava flows and shield volcanoes. Explosive eruptions. Explosive eruptions occur when highly viscous magma traps gases, leading to a buildup of pressure. When the pressure is released, it can result in violent explosions that eject ash, rock fragments, and volcanic gases into the atmosphere. Explosive eruptions can produce pyroclastic flows, ash clouds, and volcanic bombs, posing significant hazards to nearby communities. Volcanoes are awe-inspiring manifestations of the Earth's dynamic nature, capable of both creating and destroying landscapes. Understanding their formation and behavior is crucial for mitigating the risks they pose to human populations living in their vicinity. While their eruptions can be devastating, volcanoes also play a vital role in shaping the Earth's surface and maintaining its geological balance. As we continue to study these natural wonders, we gain a deeper appreciation for the forces that shape our planet. The eruption of a volcano can unleash a variety of hazardous phenomena, posing significant risks to both human life and the environment. Some of the key hazards associated with volcanic activity include pyroclastic flows. These fast-moving avalanches of hot ash, rock fragments, and volcanic gases can race down the slopes of a volcano at speeds exceeding 100 kilometers per hour. Pyroclastic flows can incinerate everything in their path, making them one of the most deadly volcanic hazards. Lahars. Lahars are volcanic mudflows that occur when heavy rainfall or the rapid melting of snow and ice mixes with loose volcanic ash and debris on the slopes of a volcano. These fast-moving slurries of mud and debris can devastate communities located downstream from the volcano, burying buildings, roads, and farmland beneath layers of sediment. Ashfall. Volcanic ash consists of tiny rock and glass particles that are ejected into the atmosphere during an eruption. Ashfall can blanket vast areas downwind from the volcano, disrupting transportation, damaging crops, and posing respiratory hazards to humans and animals. Lava flows. While lava flows are typically slower moving compared to other volcanic hazards, they can still engulf structures and infrastructure in their path. Effusive eruptions that produce lava flows can result in the gradual buildup of new land and the formation of volcanic landscapes over time. Gas emissions. Volcanic eruptions release a variety of gases, including sulfur dioxide, carbon dioxide, and hydrogen sulfide, into the atmosphere. These gases can contribute to air pollution, acid rain, and climate change, with potential impacts on human health and ecosystems. To mitigate the risks posed by volcanic activity, scientists use a variety of monitoring techniques to track changes in volcanic behavior and provide early warnings of potential eruptions. These monitoring methods include seismic monitoring to detect earthquakes associated with magma movement beneath the Earth's surface, gas monitoring to measure changes in the composition and concentration of gases emitted by the volcano, ground deformation monitoring to track changes in the shape of the volcano's surface, which can indicate magma movement. Armed with this information, emergency management agencies can develop evacuation plans, establish exclusion zones, and provide timely warnings to communities threatened by volcanic activity. In addition to monitoring, scientists also study past eruptions to better understand volcanic behavior and assess the long-term hazards posed by different volcanoes. By combining geological fieldwork, remote sensing data, and computer modeling, researchers can develop hazard maps and forecasts to inform land use planning and disaster preparedness efforts in volcanic regions. Volcanic eruptions are natural phenomena that command both respect and caution. While they can have devastating impacts on the environment and human society, they also play a crucial role in shaping the Earth's surface and supporting diverse ecosystems. By studying volcanoes and implementing effective monitoring and risk mitigation strategies, we can better prepare for and adapt to the dynamic forces that shape our planet. Beyond their geological and environmental impacts, volcanoes hold cultural and economic significance for many communities around the world. Throughout history, volcanic landscapes have inspired myths, legends, and religious beliefs, shaping the cultural identity of indigenous peoples living in volcanic regions. Volcanoes have been revered as gods or deities, feared as harbingers of disaster, and celebrated as symbols of strength and resilience. Moreover, volcanic soils are among the most fertile on Earth, making them ideal for agriculture. Volcanic eruptions can deposit layers of nutrient-rich ash and minerals, rejuvenating the land and supporting abundant plant growth. In regions such as the Pacific Northwest of the United States, volcanic soils have played a vital role in the cultivation of crops such as grapes for winemaking. Tourism is another important economic driver in volcanic regions, attracting visitors from around the world, eager to witness the raw power and beauty of these natural wonders. Volcanic landscapes offer opportunities for hiking, sightseeing, and adventure tourism, generating revenue for local communities and supporting small businesses such as hotels, restaurants, and tour operators. Despite the risks posed by volcanic activity, many communities have developed resilience and adaptation strategies to coexist with these geological hazards. Indigenous knowledge and traditional practices often play a crucial role in these efforts, providing insights into how to live in harmony with the land and mitigate the impacts of volcanic eruptions. For example, communities living near active volcanoes may have traditional warning systems based on signs in nature, such as changes in animal behavior or the smell of sulfur in the air. Additionally, local folklore and oral histories often contain valuable information about past eruptions and their effects, which can inform disaster preparedness and response efforts. Modern technology and scientific expertise complement these traditional practices, providing communities with access to real-time data and early warning systems. By combining indigenous knowledge with scientific insights, communities can develop comprehensive risk reduction strategies that draw on the strengths of both approaches. As our understanding of volcanoes continues to evolve, so too do our efforts to monitor, mitigate, and adapt to their impacts. Advances in technology, such as remote sensing, drones, and artificial intelligence, are enhancing our ability to study volcanic processes and forecast eruptions with greater